Elasticity of demand. The demand function P, or P as the D of X, P as the price per item at which the consumers are willing to buy X items. And also the revenue is computed by X times the DX, or the number of the items times the price per item. And we know that the demand function are always decreasing, indicating that an increase in supply will result in a decrease in price since the revenue demands on both price and supply. A natural concern is whether an increase in supply will result in a percent price change so small that the revenue increases, or a percent price change so great that the revenue decreases. Economists have developed a concept called elasticity of demand for determining just what effect can be expected. So we analyze it by these steps. So the delta X, which is the change in quantity demanded. The delta X over X is the percent change in quantity, where the delta P is a change in price. Delta P over P represents percent change in price. Now we're gonna find the ratio or put them together as a ratio of the percent change in X and percent change in P, or the delta X over X divided by delta P over P. Rearrange the expression as a division form and rewrite as the product of the reciprocal. From this quantity, we're gonna rearrange this expression, the delta X over delta P, as the reciprocal of the delta P over delta X. And the next step, we're gonna let delta X approach 0, or the change in item or the change in quantity gets smaller, where P is the demand function dx. As we take the limit, the quantity delta P over delta X approaches the P prime, or the derivative of the price function, or the derivative of the demand function. Now we can see this as the quantity turns out to be negative inside, because the X as a quantity will always positive, and the dx, or the demand function, always positive, but the rate of change of the demand always negative. That's why overall of this quantity can be negative. Now we form the formula for the elasticity by including the negative side to see E as a positive number. On the side notes, if we rearrange the term, we can see the x times d prime of the x equals negative dx over E, because we're going to use it to see the relationship of the elasticity and the revenue. For the revenue function in the form of x times dx, we find the derivative using the product rule. Have the x times the dx plus the derivative of the x times dx, where the x times dx is replaced by the negative dx over E. We can see the relationship of the r prime and the dx and the E as r prime equals dx, or the demand function, multiplied by 1 minus 1 over E. So we can see the properties of elasticity of demand relating to the r prime, or the r, or the revenue function. As, as E greater than 1, this quantity will be greater than 0. So the dx times quantity greater than 0 makes r prime to be greater than 0. That results revenue increasing. And we say the demand is elastic. For E less than 1, the quantity in the parentheses will be less than 0. So the quantity less than 0 times dx, or the demand function, the r prime going to be less than 0. That means the revenue is decreasing. This one, the demand is inelastic. If E equals 1, the r prime going to be dx times 0, or the r prime is 0. That means the revenue reaches the maximum value. This one we call the demand has unit elasticity. As we see the trend of the graph here, the demand function is always decreasing. That's why the D prime is negative inside. At one point, the elasticity The E is 1 or the unit elasticity. For E greater than 1, the revenue is increasing. For E less than 1, the revenue is decreasing.